Hello, everybody. How are we doing? Happy Tuesday, whatever day it is, whatever Tuesday. Yes. So there is a town hall meeting, a Dr. Jackson town hall meeting today. I guess at 3:00. Which I don't know if I guess it's probably being recorded and whatnot, so that will be available as well. But of course, it's right smack in the middle. I think it's today, isn't it today? So if you do choose to not be here today because you want to watch the recorded version of the lecture for later, that's certainly an option. But I do encourage you to, be here for the lecture or to be at the town hall meeting, one or the other. So there's that. All right. So in other news, I have actually gone through and I think I've downloaded. There's one or two last. I have this weird criteria that I like to have, to know exactly where the submissions are and look at everything before kind of starting to assign grades to individual projects, because I like to, not, although I don't necessarily grade on a curve, I do like to get a feeling for where everybody's at, especially to make sure, that what material was covered, what material wasn't covered, what might have been, obvious and not obvious, and so on. So I have gone through all that. Everything looked really good. So I was pretty impressed. I reached out to a few people just to make sure what's going on. We'll have grades up hopefully by Friday. So don't worry. That basically, when you don't hear from me, that's usually a good thing. I like to track down anyone who has issues as quickly as I can to make sure. So I have to give you all a real big thumbs up in terms of the number of issues that there actually were with Unity teams. There were a few new ones, but overall, I think this is one of the best percentage-wise, the fewest kind of lingering issues with regards to the Unity team submissions. So thank you all for that. I really do appreciate getting that out of the way. That's a good one. It's nice having that out of the way. And let's see what else. So we are getting deep into the midst of Project 2 already. So we're going to want to discuss that a bit. And so that will be part of today. Let me do a quick, yes. Did I? Oh, I did not. Okay, hold on. Yes, I started the YouTube stream, but I did not post the link. All right. Sorry about that. It's such a bunch of things to remember. Okay, there we go. That's better. All right. All right, now we're getting into it. So let's talk a little bit. What I want to first do is talk a little bit about Project 2. And then we'll go back to our snowsuit wearing kid and kind of talk about how things would be potentially implemented. And we'll have to revisit when the due date is, but that's probably not all that far away, so don't be behind. So hopefully if you can follow along with the examples that we've had in class, then you're going to be in relatively great shape anyway. So let's talk about Project 2, the Apple Picker. So now, first off, before even looking at the details on this one of the important things is that you should put into place the sample kind of main menu and then your different games. I don't want a new submission for each of these. I want you to use the existing submission that you've made through Unity Teams, that actual project. I want you to continue to use that one, even if it means, modifying things and so on. Put the main menu in place in there and that sort of thing. Absolutely do that. Don't want new submissions. We have it all in place. Unity Teams is working. We want it to continue working. So that's a good thing. So get your menus working. That's going to be a requirement of this project. Okay, one of the things. Then here's the other requirements. So basically, this is the infamous apple picker. It's based on an Activision game called Kaboom, where there was like a mad bomber that would move across the top of the screen, dropping these bombs that would have sizzling fuses. And then if you had to catch them in a set of 3 baskets, and if you didn't catch one, it would actually fall to the ground, and boom, it would blow up, and you would lose a basket. Okay. And when it fell to the ground, if multiple bombs had been dropped, because progressively over the course of time, the bomber or the apple tree is going to drop the apples faster and faster. So it will get to the point where there will be multiple projectiles in the air at once. Right. So one of the cool features of the game is going to be that if multiple things are in the air at once and you miss one, you lose a basket, but all the rest that are in the air have to be dealt with and destroyed immediately. Right. So it kind of gives the player a chance to kind of catch their breath. Okay, so here we go. Project 2, Apple Picker. Enemy moves. The enemy, in our case, it was the snowsuit kid, or I showed an apple tree, or the scarecrow, moving left to right across the top of the screen. You can use transform.translate or position.x plus equals, or the best way to do it is to actually use some sort of rigid body, probably either kinetic, since we're going to script the motion, or you can even, if you wanted to, you'll see in some of the examples, we can directly manipulate the snowsuit kid as if it was just an object that we could use translate or position to be modified there. That enemy is going to drop objects at random by instantiating prefabs that are going to have rigid bodies on them that causes them to move, cause them to drop, right? So they're going to have dynamic rigid bodies that are going to give them gravity to drop, all right? You're going to want to keep track of every item that is dropped in a list, okay? The reason for that being, if the player, if they miss an item, you're going to need to delete everything in that list in order to give them a chance to catch their breath, like I mentioned, all right? So we're going to use lists to maintain those objects. The enemy will change direction if it hits the edge of the screen playfield based on a decision, not based on a collision necessarily, right? The enemy should also randomly change direction between the edges of the screen. So even if it doesn't hit an edge, there should be some sort of random behavior so that we can kind of, make it exciting for the player. It shouldn't just be left, right, left, right, left, right. It should be left, right, maybe left, maybe right, and so on, kind of switching around. Somebody's got their mic on and kind of bumping into things, so be careful. Okay. Where was I? All right. So enemy is going to randomly change direction between the edges. We can use random and invoke, which is I started showing invoke last time. That was the teaser. The enemy should incrementally speed up their motion and the apple dropping over the course of play. All right. So this is going to be a progressive game. This is going to be a real thing. It's going to get harder to play as we go. The player is going to have 3 baskets initially. They're going to have 3 baskets to catch the items. We're going to demonstrate how to use an array, right? Since we know that the player is going to have some fixed number, perhaps, or maybe we want to leave room to have up to 5 baskets, we're going to use an array for that. All right. You could use a list, but I like to demonstrate the use of arrays, unless you've got some real crazy plan and you want to use lists for both of them. All right. The player basket movement will be controlled by the mouse. All right. So we're gonna do some exciting stuff. We talk about the mouse and input action today. If the player catches an item, the score increases. Normally, if you decide to get real fancy and have something like the pitchforks falling, like I had in my scarecrow version, maybe that causes the player to lose a basket if they catch that. They don't increase the score for catching that one. They have to avoid catching those. But normally, if a player misses an item, the player loses a basket, and all of the apples that are in midair also get destroyed to give the player a chance to catch their breath, right? The game will end when all 3 baskets are lost. It's an arcade style, 3 baskets lost, play ends. Some other features. You will also have player preferences used to save and load the high score. So every time you play the game, it will already have the high score loaded. And if you beat the high score, it will show that and indicate what the high score is. All right. And there should be some use of a start scene and game over scene. How well or how tightly you integrate that with your, you can, integrate that with your other main menu as well. So technically the starting scene could be, if you get creative, could be the start scene, your main menu if you wanted. Maybe you have a game over scene though that's special that says, okay, the game ended. A lot of you did that in the first project anyway, so that was good. There should of course be sounds, right? A game without sounds, unless it's obviously for a purpose, it looks half finished, right? Unless it's really supposed to be that way, in which case it's obvious that it didn't need the sounds. But in our case, we want to have sounds. So when an item is dropped or spawned, it should create a sound, whoop, whatever. When an item hits the ground, splat, it should have a sound, or maybe it's the sound of the basket being destroyed or the building falling, whatever. And there should be some other item to indicate when the item is caught. So a good sound for that. So you're going to wind up with having at least 3 sounds: the spawning sound, a fail sound, and a success sound, right? Success is when you catch an item. Fail is when you miss an item. And spawn, well, that's up to you. It could be the sneeze sound because it's a sneeze game, whatever. And background music, always appreciated. We always love to get background music. All right. Bonus ideas include things like using singletons to manage your lists, dropping multiple types of items for different scores, dropping items that could be avoided, rewarding the high score by restoring a life or doing something else interesting. Delay the destruction of dropped items in a sequence like Kaboom. The actual Kaboom, the dropped items that were destroyed would explode one at a time in kind of a very cinematic way. What if you had multiple enemies? What if you had power-ups to change your basket behaviors? What if you could fire a weapon or deploy a shield or destroy all dropped items or invulnerability or something like that? You can imagine, get creative like that. All right. So hint-wise, now maybe you have multiple scripts now potentially. And there may be things like the enemy, the snow kid who moved left and right across the screen, the game manager, which initializes the scene, manages the score, exits gameplay when we're done, the basket or player's behavior, right? Move according to the mouse position, catch the items, and so on. And then the dropped items, they may need some sort of behavior as well. Do they blow up off the screen and so on and so on? Let's see. I may edit those a bit here, but that's the gist of Project 2. Yes, question. I have not assigned grades yet, but I have looked through them. Unless I've reached out to you, you can consider that you did better than reasonably well. So I was very impressed with things. So usually what I do is I try to get a hold of anyone who had any issues first before I assign all the grades, just to make sure that there was, not some kind of common thread or issue that I missed or something like that. So, so no news is good news in this case, but there will be grades by next class. Okay, so basic input. We're going to talk about a wide variety of input today, but we're not going to necessarily use all of it. We're going to use, for the next project, we're going to use one of the more sophisticated pieces of it. And Unity actually has a couple of different methods of input, including 2 different input systems. So you may hear about now with Unity 2020, and it's been around for a couple of iterations now, there's a new input system that's supposedly a lot more flexible and forward thinking, but it's just, I find it to be a bit more set up and kind of tricky to use. And the basic input system and the legacy input system are really good for getting the ideas across. So we're going to actually use those today, or for the project even. All right. So let's see. Let me zoom this up a bit here. All right. Basic. Yes, we can do that as well. So all of these techniques, the nice thing about Bolt is that it's basically a mapping, right? So depending on how far we get through the basic implementation here, I think I do have a video of creating the basics of the Apple Picker project all in Bolt. So if I don't get to cover it today, I'll at least point you to a video, and it'll be just like, it's new to you sort of thing. But this is actually a good project to kind of jump in with Bolt as well. So we will get to that. But the basic ideas are going to be similar. So there's two basic types of input that is built into PCs. And this is in a general case, right? Your general computer that you have, you will normally have a mouse or maybe a touchpad, which is sort of emulating a mouse for the most part. And you have keyboard input, right? When you have the mouse has various things that you can do. You can click the mouse button, you can hold the mouse button down, you can release the mouse button, and you can get the current position of the mouse, which can be modified according to whether or not the button is dragging, or if you're in a selecting mode, so you have certain types of modifiers, right? There's the click drag, those sorts of things. But the general idea is you've got buttons and you've got a position as far as the mouse is concerned. As far as the keyboard goes, you have the action of not just pressing a key, but you may be holding down a key for a certain amount of time. You may be also have an action assigned to releasing a key. And for all of those things, you generally will have the identity of the key pressed. Sometimes you also have certain keys that modify other keys. Like if you have Shift S to get capital S versus just pressing the S key, you might want to, treat the S key the same no matter what, if it's capital or lowercase or caps lock, whatever. But that's the general idea. Now, because we are working on real-time things that, have state and have, time passing, we have this notion of also like holding a key down, right? There's the initial press of a key, the first time we encounter that a key is pressed. And then you could say, okay, every subsequent time, is the key still pressed? That's what that notion of holding a key down is, which is different than the initial press of the key. Like you can imagine, the first time you fire a weapon at someone versus if you're holding it down, do they continue? Or if you're jumping, do they jump continuously when you're holding down the space bar, or do you have to hit the space bar again? Things like that. They're all input. All right. Keyboard input. We're going to have associated with it, we're always going to have this key code that's going to store preset values for any key on the keyboard. So we have these key codes in Unity. So for example, we have keycode.space, keycode.a, keycode.right arrow, right? This is an enumeration. The key code is an enumeration that has a bunch of different values that are each unique. You're always going to get keys reported individually. Keys don't get reported simultaneously. So you're going to get, the space key once, and then you're going to get the A key, and then you're going to get, right, for each time you work with it, right? So that's an enumeration is going to tell us, this is the space key, this is the A key, this is the right arrow. And these are all values that are enumerated according to the keyboard, right? They're associated with the keyboard. They're the set that belongs to the keyboard. So, for example, we can ask to see, let's get a key, and is the key the space key? So what this means is input.getKey returns true on every frame that the space key is pressed. So it's saying get the keyboard state, and the key we're interested in is the space key, the space bar, right? Get key, that's the one that does that. It says, okay, is the space key pressed? Not the first time, but any time the key is pressed. So if you're holding it down, it's going to continuously return true every time you call it. You could also ask input.getKeyDown. That's going to return true on the first frame when the space key was pressed. So if you press the space key and you have in your input loop, excuse me, not your input loop, your update loop, you had if input get key down, you're going to see that happen once until you let go and press it again. If in your update loop you had if input.get key space, that would return true over and over and over again as long as the key was pressed, whether or not you let go of it and pressed it again. And then finally, you do have this option to say, well, input.getKeyUp, which is going to return true on the single frame when the space key is first released. So maybe letting go of the space bar has some action as well. So it'd be, here's the whole spectrum of, you would see get key down when it's initially pressed. We would see get key as long as it's continuously pressed. And then we would see get key up once you let go of the space bar, right? This would, by loop. So the question is this in a loop? I'm just going to repeat that for the stream. And it's effectively, you would not provide the loop, but you would put this in your update routine, right? The update routine is going to be called over and over and over again every time a frame is drawn, right? So you want to check this every time a frame is drawn, for example. Right. This would be put, normally you see this happen in the update routine. That's where we're going to implement it today. So, all right. So for example, if input.getKeyDown, keycode.space, then execute code to jump, for example. Mouse input, raw mouse input is similar. Each mouse button has a different default index, though. It doesn't have a code associated with it. It has a number. So 0 is the left mouse button, 1 is the right mouse button, and 2 is the middle mouse button. It's a little bit weird. Subsequent buttons after that are 3, 4, 5, 6, and so on. But the assumption is that once upon a time, sometimes there were single button mice. Thank you, Apple. I guess it was mostly that early Macs had that. So that would be button 0. And then we had 2 button mice. So that's why we had 0 and 1. And then by the time you had 3 button mice, we knew that all mice had, or any mouse button that had 3 buttons also had 2 buttons, obviously. So we wanted the things to map similarly. So that's why they this kind of came in after the fact. So the middle mouse button was sort of optional on 2 button mice, or on 3 button. You know what I mean? So the highest level of compatibility, they wanted things to act the same. So that right mouse button always did the right mouse button thing, and left mouse button always did the left mouse button thing, and so on. We have get mouse button, which returns true every frame the left mouse button is pressed on, for example, because this is mouse button 0. So this should sound sort of familiar, sort of similar to how the keyboard worked. Get mouse button returns true on every frame. Get mouse button down returns true on the frame the first time the button is pressed. And get mouse button up returns true on the first frame where the left mouse button is released. All right. So similarly, maybe you wait for the user to press a button to actually start the game. So you would wait for get mouse button down and then go ahead and start the game. Right? You wouldn't start it every time the user was get mouse button. Right? That's why you only start. You only want to do it once on that initial press, for example. All right. So here's the gamut, or some more of the potential mouse inputs. Now, the cool thing here is you notice these are not input. These are not, if I go back over here, input.mouse button down. These were polling. We call this polling because they're checking over and over and over again, right? You call them in a loop or in the update routine. Right? That's where they're called. A good question about that. Now, on the other hand, we have these Unity event functions that are the ones that begin with on. Right? So in this case, we can actually create a function that is triggered when the mouse button is pressed. So on mouse down is an actual method we can add to our component that will be called when the left mouse button is first pressed over this particular object, right? The object that this component is on. On mouse up triggers when the left button is released after clicking this object. On mouse enter when the cursor first moves over this object, right? So we can use the mouse to interact directly with an object that it's on by using the on mouse events. These will be triggered just like the update routine or just like the on collision that we showed last week. Okay. So we have a couple of different options here. None of these are really required for our second project, though. So lots and lots of options, but it's not, we're going to go a fairly simple way to do this, right? So you'll notice all of those, by the way, all of these had sort of click events associated with them. But what if you're just interested in the position of the mouse, where the mouse is on the screen? Right? So for that, we have something else called input.mousePosition, which was similar to input get key and so on, right? We can poll, we can just ask for its position at any particular time. We could say input.mousePosition, which returns the current position of the mouse, right? So any routine can call just input.mousePosition, refer to that global variable effectively, okay? So we can get the position of the mouse at this instant, right? So let's take a look at that. Let's stop there. Let's do a little coding. Do a little coding here. All right, we have our Snow Kid. And what was going on with Snow Kid? Snow Kid was up at the top of the screen here. And we had these baskets at the bottom, and Snow Kid was dropping soldiers. Okay, but these baskets aren't doing much of anything. So we want to do something more incredible with those baskets. All right. Now, the game manager at this point was instantiating these chests for us here. If we go look in Game Manager 2, I'm going to open up Game Manager 2. And that was the thing that created these chests, just sort of as static objects that really didn't do much of anything, right? So that's probably not really where we want the chests to be associated or to be built, because the chests actually belong to the player, right? The player controls the behavior of the chests, okay? So let's create another object, create an empty object called player. Right. Now the player may or may not have any visual element of its own. Maybe it just has the chests that it can carry around. So the player is just sort of an invisible object for the moment. And let's see, let me go ahead and I want to move the player. And the odd thing is that, of course, the camera is also there. So let me move the camera for a moment. There's the player. Where is the player? Normally I see a little indicator on the player. Oh, there we go. Player. All right, so I'm going to move the player down here towards the bottom of the screen. And for now, I'm going to turn the camera back on just so I can see, okay, there's the screen, right? There's what's going on here. That will be the screen when I play the game. If I click on player, now I see, okay, the player, I've moved the player towards the bottom of the screen. I'm going to go ahead and move the player even further towards the bottom of the screen. I'm going to say, the player is going to be at, I'm going to make it -4.5, right? And the player doesn't have anything on it right now. It's just an empty object there. I choose the move tool and then selected the player there. Okay, that's the question. How did I get the gizmo to show up for the player? And that was just using the move tool. The W key would have got me there, I guess. Yeah. Use my keys. Use my keys. All right, so there it is. We have the player. Now, let's add a component because we want to add a method of moving the player. So for now, I'm going to go ahead and put player behavior. And it will be a new script. If I was using Bolt, I would go ahead and say, create a Bolt graph for this. And maybe we'll do it both ways. We'll see. So here's player behavior. And now, yeah, okay. So let's go ahead and building it. And come on, player behavior. There we go. So here's our player behavior. And it starts off, it has nothing in it. what we want it to do is we want it to create the baskets. Okay, it should be in charge of the baskets, and then that should not be it. Here, let's. Our baskets were in our game manager before here, right? So let's put that in our player behavior. Now you'll notice it immediately complains about this chest prefab because it doesn't know about that. So let's create the chest prefab there. So for that we say public game object, and we call this what? Chest prefab, right? Right. And it will go through, and we're just going to create these chests. And now, one of the things we're going to want to do, well, let's just leave it as they are for a moment here. So we'll say save and come back to our game. And we'll hit play. And if all is okay, we wind up with 3 chests here. They are at that position in the world. And if I take the player, if I move this player back and forth, you'll notice the chests do not move. As we want them to move, they should move with the player because they belong to the player. They should be children of the player. And we don't see them as children of the player right now. They're just other objects in the scene. Oh, wait a minute. Huh. Hold on. Even though that's... Wow, I'm surprised it even let me do that. Oh, no, I know why. Because it didn't... All right, let's fix this. All right. First off, I need to make the Lego chest, point the prefab at that, and I must not have saved the game manager prefab, or the game manager, maybe I didn't save any of those. So player, call that. That probably just failed. Yeah, variable chest prefab has not been assigned. So it did complain. Just let me play anyway. We do that. Let's go to game manager and tell the game manager, nope, game manager, you do not create the chests anymore. Now it's up to the player to manage its own chests. Okay. So now let's see if it does that. I play again, and it should do the same exact thing. Everything looks normal, except that's moving. And if I select the player, and now in order to select the player, what I'm going to do is I'm going to split this. All right, so we can see the game playing, but we can see the scene. And I'm going to move the player in the scene, but you'll see nothing happens. The chests don't move. But I want the chests to move with the player. So to get that to happen, I have to modify how I'm calling instantiate there. Okay. Instantiate right now is saying, okay, chest prefab, and here's the location of the object. But what I really want to do is I want to instantiate it slightly differently. Now, instantiate, there's actually a whole bunch of different types of instantiation that you can do. And you'll see if your IntelliSense is working correctly, it will tell you there are 1 of 10 different types of instantiate that can get called. So for example, look at this one. Object instantiate original and parent. Clones the object original and returns the clone, but it has this transform parent potentially there. Okay, instantiate in world space. Okay, there's the one we normally use with a position and rotation. Here's the one. We can clone the original object and return the clone, but it can have a parent. Right? So it is the original, a position, a rotation, and the parent. So here, if I put transform Now, it's going to create this object. It's going to instantiate this object at that position, but it is also going to make it a child of this object that this is on, of the player. And that has a big advantage. As I come over to here and I press play, the advantage is now that they will move with the player because they are children of the player. Now look, I'm already sort of playing the game here. I can move and catch the soldiers as they're dropping. Right. So obviously, this is a pretty good thing. The player now owns its baskets, and I can move the player around to catch the objects. But moving the player around in the scene isn't exactly what I want to do. Instead, I'd much rather use the mouse input. So for now, let's go back to player behavior. And in update here, let's print input input at mouse position. Okay, this is just the brute force way to do that, just so we can see what the mouse position is. Okay, so this is just for now, and it's going to print it a whole lot. It's going to print this many, many, many times a second. So far more than I really want it to. And let me make sure I save that. Let's go too fast. Yep, I did. I'm getting good habits here. So I press play, and I will click console here, and you'll notice it's saying negative 756, 469 over and over again, even though I'm moving the mouse around. Now, that's odd. Okay. But the moment I click on the game screen, see if I click on any other scene, nothing happens. If the game scene is active, come on, game scene be active. Oh, I'm just scrolled way too far here. It stopped auto scrolling. Let me pause for a second and restart it. This is the one disadvantage of it printing so much. So let's clear that and play again. And I'll move the mouse around. All right, so we see that the mouse changing there. Right. Now, the interesting thing, I'm going to move to the edge here, and it goes to negative, or it goes to 0. And if I go to the bottom here, it goes to 0. So the mouse position, as far as the game is concerned, 0, 0 is here, and I wind up with what? A number that's 545, 305 up here. But the problem is if I change this size, it's still 0, 0 down here. It should be. But now up here, it is 882 by 494. Now, the reason that is because the mouse is actually returning pixel coordinates according to the screen. Right? It says, all right, this is 0, 0, this lower left-hand corner, that's 0, 0, but everything else is in terms of pixel coordinates, which isn't too good because most of our other coordinates are what we call world coordinates. They're the position of the objects in space inside the game. All right, so there's a problem. Yes. Question? Depending on how you've kind of stretched the screen, absolutely, yes. If I full screened and your resolution was 4K, absolutely be different. Yes, and that's a problem. However, with proper practice, it is not a problem at all because there are ways around this. All right. So we have this notion of screen. There's 3 things we have to remember now. All right. So there's the screen coordinates. And so the screen coordinates are sort of arbitrary other than the fact that we have 0, 0 down at this corner. And we have some maximum number of pixels to the left and up over here. But now we have a couple of other objects in our scene, right? One of the things that determines how we see things here is this camera, okay? So you can imagine the camera, and let's go to the scene now, right? So here's the camera. Now the camera sees things between 0, 0 and 1, right? The camera has a space that it defines that is not at all in terms of pixels, right? And then that we have beyond the camera, we also have the world coordinate system, which is now based on meters in this kind of magical world that is inside the engine. So we have a couple of different systems of measuring and a system of kind of pointing where things are. And thankfully, Unity provides us with the tools we need to deal with that, okay? So normally mouse position, you have to think of mouse position as being linked to the physical device, right? So the mouse's position is this kind of combination of, you know, a relative offset according to the hardware device, and then ultimately pointing to a specific pixel on the screen. That's what mice normally do. Right? So beyond that, we now have these other kind of spaces within Unity, right? We have this screen point, which happened to be how the mouse works, with 0, 0 in the bottom left corner, with screen.width and screen.height to the top right corner. And screen.width and screen.height aren't really the screen dimensions, but rather the window dimensions. If your game happens to be full screen, they will be the screen, but they may very well be the window dimensions, right? So that's the one type of display space. The next is this viewport space, and that is the sort of the image of the world that Unity is, or the portion of the world that Unity is presenting you with at the time. So this viewport point is more what within the camera, within what the camera sees, depending on, you know, if you're using just kind of the normal methods. You'll see it go from 0, 0, 0 at the bottom left corner to 1, 1 at that upper right corner, okay? So the nice thing about that is it maintains the same relative values. So if you're pointing to the center of the screen, it will be 0.5, 0.5, no matter what your resolution is. And this is a floating point number instead of an integer number. And even the screen height and your screen width, for some reason, we can actually be kind of between pixels, depending on the accuracy of the mouse. But anyway, so now viewport point, that is far more independent of resolution, right? And then we have the third and not least, which is the world point. The world point starts at 0, 0, which is the center of the camera. Normally, it starts off center of the camera, going negative and positive. Now, as the camera moves around in the world, that may actually change. But so world point is your world location, right? So when we have these different choices, Unity also provides us a way to convert between them. So we can say, oh, okay, given a certain point on the screen, please convert that to a point in the world, for example. Or if we have a point on the screen, give me a point within the viewport, and vice versa. We can say, okay, given a certain camera, convert a certain world point to a viewport point, or a world point to a screen point, and then a viewport point to a world point, viewport to a screen point, and so on. The one that we're most interested in for now is this first one, because with that we can say, okay, given the camera that we're currently using, and we only have one camera right now, but given the camera that we're currently using, please take this screen point, which is our mouse position, and convert that to a world point, which tells us where in the world we want our object to be, right? So that allows us to convert and make an object follow the mouse. Okay. So the idea to make the object follow the mouse, we want to attach a new script to an object or have some behavior associated with that object. We have, like, for example, we have the player script that we just created. And on every frame, we want to find the position of the mouse and set the object's position to match that. And that is going to require us to convert from the mouse's position as a screen point while the object's position is a world point, right? So we're going to be using a combination of things to get there. All right. So we have the input mouse position. We can use transform.position, which is going to move an object. We're going to do it kind of the brute force way in the case of the player. We're not going to even use a rigid body for it because the player doesn't really have a rigid body, doesn't have physics. It's this kind of ghost-like thing in the world that we're just going to move its transform around, right? It's not really a true object in the scene. So we're going to use this transform position. And we're going to use this conversion, camera main screen to world point, to move it. Right. So let's give that a try. So the mouse moves around on the screen. We want the player to follow the mouse. So player behavior. Right now, it's printing the mouse position, but I don't want it to do that. But I know I want to use this input mouse position. Now, we'll notice mouse position returns a vector 3, input mouse position. All right. And you'll notice it says get. So this is a getter. There's a special kind of hidden function behind here so we can get the mouse position. You notice it doesn't say set. We cannot set the mouse position. We can only get it using input. All right. So main camera, that one's a give me, right? That's the object we're going to use, or the camera.main. Main, I think. Yeah, camera main. There we go. Camera.main. That is shortcut for the main camera in the scene. We can use that one. That's fine. And we want to convert from screen point to world point. Wants us to pass in a position. There's the position. Right. Now, if we wanted to move the player, we would say, well, transform dot position equals that. So that would move the player's position to the world point position of the mouse. Piece of cake, right? Let's give it a try. All right. Now it is moving it around. And you can see that we seem to kind of be catching the soldiers, but there's a problem with we don't see it on the screen. What's that? Yes, that is absolutely supposed to happen. That is absolutely supposed to happen. Okay. And I'm going to explain why, or I'm going to give you the way around that. And then I'm going to pause to let you all get that working. And then we're going to talk about why that happens. Okay. We're going to say vector 3 position temp position equals that. And we're going to say temp position dot z equals 0. And you see that work, right? So I'm going to put this code on the screen right now. There's not much code there. You'll leave that on the screen. I'm going to pause for just a minute, and I'll be right back. And I want some suggestions as to what happened. Why did I need to do this with Z here? Don't answer me yet, but go ahead. I can just give you I'll be back in 1 minute for you to get that. And I want everybody to have some object following their mouse around on the screen by the time I get back in 2 minutes. Okay, was that 2 minutes? Okay. So the question is, does everyone have... All right, I'll do a quick poll here. Did you get an object to track with the mouse? Okay, very good. So we got a bunch of people that did, hopefully. All right. Does anyone have a theory as to what happened and why this was necessary? Okay. So again, repeating for the streams for posterity, it was stated that the camera position, the theory is that that this value that's returned by camera main screen to world point it has some Z value that is less than the camera's position. And that's a very good theory, and it's very, very close. It's actually exactly the Z position of the camera. Okay. And if your Z position is the same as the camera, you can't see it because you are on the plane of the camera, right? Because what's happening here, you got to remember that screen is, in this case, the screen is a two-dimensional device. It's a flat plane. And this mapping that's occurring assumes that it is the camera's notion of where that would be in the world, right? So it just says, okay, the Z position, if you're on my plane as the camera, it's -10. So, so up in here, normally, if we said, the camera by default has a Z position of -10, and that's so that we can see everything on this plane. We have to be back, right? If I come over here and I say, okay, here's a view of where the camera is in the world versus where, There we go. You can see the little Snow Kid up here. Snow Kid is at 0, and the camera is negative 10 away from that on the z-axis there, right? So if I were to change that, yeah, I can go back and do that. Let's see. This is a fun demonstration. If I just said, and I didn't set that z to 0, and I press play now, you'll see that there they are, right? There they are on that plane, which is the camera's plane, as opposed to the plane that the player is on, right? So our kind of odd orthographic view, but we're on the plane of the camera at negative 10 when we want to be at the plane 0. Sometimes it's fun to actually take the, it's kind of weird how the mouse is moving. I've come over here and assume it's going to move, of course, because it's over there. So it's kind of fun to see what it's thinking the world kind of looks like here. We can kind of, so there's an even better example of it, right? There's our objects over there. Yeah. Because remember, the engine is always thinking 3D. It just has some optimizations and shortcuts to let us do things in 2D really nicely. All right, so we'll go ahead and we'll change that. Now, what I recommend is to do it in a little bit more of a sophisticated way than this, right? Normally what I would do, because now, say I happen to be in a game that's not a 2D game, or maybe I'm doing something interesting, like I'm doing some kind of parallax layers, or, you know, and that's another, if you don't know the term parallax layers, don't worry about it yet, but maybe I have like multiple layers going on my screen, or I'm moving something that isn't necessarily on the 0 at z equals 0. So normally what I recommend, instead of this here, is I would say to do this. Not quite that. I just want position.z. Okay. So this way, I'm keeping the z position of this object, right? Now in this case, it's going to be 0 because it's going to say, okay, the player was at 0, transform.position.z. That should be 0. It's not the camera's position. It's the object that I'm on here, which is the player, right? Which should be 0. And I'm going to keep that the same, right? Because I don't want that to shift around. So now, similarly, it should just work. Right? So I play and it works. Now, this is not the behavior I want for the game, though. It's close, but it's not quite there. Normally in the game, sorry, question? I want to somehow lock the y value. I don't want the y value changing, right? I don't want to be able to do this. I just want the x value changing. Right? So how would I do that? What would be the easiest way to do that? Exactly, right? And the nice thing about doing this way is I don't have a hard-coded number, right? So if I move it around in the scene, it'll keep that position in the scene, right? So now, well, I better make sure I do it there too. That would be useful. So now it's preserved where it is in the scene, and it will only change that x value. Okay, so now y doesn't matter, but x matters. So we've pinned the pinned the y and the z. So now our mouse is doing the right thing. Okay. So the basic game mechanic is kind of there, right? We're moving the player and whatever objects the player has left and right. And we have the enemy, which is kind of moving left and right automatically. And our dropped items are just happening, doing the right thing as well. So we're in pretty reasonable shape there. All right. Okay, double check your code here. Yep. It doesn't matter where you put it. I mean, if you put it before this, then it wouldn't work. You put it after this, it wouldn't work. Do you have an error in your code? Is it actually compiling? Did you save your code before? I know I remember it too, but sometimes I've remembered wrong. So this code will work, though. This is the code you need. You could do something even more interesting, like copy into temp position the value of transform.position and then only change the, you can do all sorts of clever things. How you actually specifically implement this, I'll leave it up to you. But this is the general mechanism for what we want to do now. So what we also want to do is start to say, well, okay, now you'll notice here, this just arbitrarily put our baskets, spread them across. We want to stack the baskets, is one of the things we want to be able to do. So in order to stack the basket, you'll see right now we had this vector 3 with a X position and a Y position. So what if I set the X position to 0, or even both of these to 0, or perhaps even one of them to I? So X is 0 and Y is 0, 1, or 2. So now we can get fancier. Now this is, so what's happening here is that these are still absolute positions. So we have to, let's see, I'm betting, let's see, just check my prefabs here, make sure I'm not, all right. Normally I want my prefabs to be at 0 and 0. And let's go back to the scene. All right, so everything is properly centered. So now what we may need to do is get this offset set correctly, right? We're going to start these things, instantiate these things with an offset in between. So I might be the position of the current. So we would say something like transform dot position dot y plus I. Oh, sorry, I'm on the wrong screen. There we go. Transform position. Should have been under update. All right. So look, I've got baskets. They're stacked. And the interesting thing, if you, as a mental exercise, let's see, let me put this out. I'm going to pause the game here. This is a tricky thing. I'm going to move them this way. There we go. Now I can pause. Okay. The first basket is actually down here at 0. The second basket is up here at, at 1, and the third basket is up here. So 0, 1, 2, because there's that offset. The first one had no offset. It was right on top of the player. So it's at 0. The next one was here. The next one was here. So that's the order they're actually in, 0, 1, and 2. So now's when we start getting fancy. We have to say, okay, I've created the baskets in this order, but I might need to destroy them in the opposite order, right? If I miss a basket, if I miss, the player falls off the bottom of this, or not the player, but the soldier, if the soldier falls off the bottom of the screen, for example, here, I need to get rid of a basket, right? If the thing collides here, it's saying, okay, I need to add to the score. So I'm going to put a little pseudocode in here. Add to the score. And up in here, I'm going to say destroy one of the baskets. What also happens? Destroy all of the other dropped items. Right, so that's the other thing that needs to happen here, right? So we destroy one of the baskets, destroy all of the dropped items. And here we need to add to the score. And that would really kind of make the game work right? Those are the two things that are missing. So how do we do that? Let's see. The time is 3:40. So we have plenty of time. Okay. So I mentioned using lists and arrays. Right? So I like to recommend, just so you get the practice of doing it, to have lists of dropped items. In this case, our soldiers here, because we don't know how many of them we're going to drop. Right? We're going to drop at least one, and then depending on how fast the game is running, depending on how crazy things are going on, we may have some, we just don't know how many of them. Now, we could arbitrarily say, well, we're probably never going to have more than 100, so maybe I'll make an array of 100, but that's not practical. That's not really making effective use of things. So I recommend using the lists for this particular item. Okay. The baskets, on the other hand, they're much more manageable. We might say, well, okay, the normal case, we have 3 baskets. So we could do something like, say, game objects. Idea is to get a basket array here now. Remember my syntax. Oh, that's not how we do it. Boy, I have too many different programming languages in my head at once here. Let's see, did I have this in here? Let's come back here. I'm going to get it right. You can suffer through this with me for a minute. So, whoops. All right. We want an array of game objects. Now, normally we would just do that, and then we would say equals All right, bad array declarator. To declare a managed array, the rank specifier precedes the variable's identifier. All right. We have now successfully declared this array, but we haven't said how many of them there are. That's not right. See? Try initializing with a new oh, I remember that. Game object. Boy, I'm just drawing a blank here. Hold on. Let's do this the right way. Let me not be a source of misinformation today. Let me open up Simple Tree. Boy. Oh, you know what? I think that's correct. Yeah. And now we would say, I hope I got, I have to, we're still waiting for that other project to load so I can see if I'm lying or not. All right, so here's Simple Tree again. Let's say skip new version for now. So in our Simple Tree here, we have the main camera. Oh, we don't want this scene. We want to be in gameplay. And in here we have the player script, the basket prefab, number of baskets. I'm going to guess I did this with lists now. Yeah, I did basket lists over there. That's an older version. Anyway, I remembered in the meantime. So now we're going to create an array of baskets. So we have 3 baskets in our array. And I'm going to run that just to make sure I did remember it correctly. There we go. So we have our baskets. And we could go one further. We could say, okay, well, let's see here. See how the player, we see the Lego chest and so on. Just for sake of argument, watch this. We're going to go to the player. We're going to say that this is a public game object basket array. And the nice thing here is the moment I do that, you're going to see over here that we have basket array size 3, and it has no elements in it to begin with, right? This is during instantiation here, or during, sorry, in terms of, before the game starts. The moment I hit play, we'll see that that will then fill up with those 3 baskets, those 3 Lego chests, right? There they are. Right, I can't really, if I paused it and I change this, I don't think I can do that. Oh, what do you know? All right, so it paused it. It reran this start to reinitialize things, filled that in. Wreaked havoc. Didn't quite work. All right, or maybe if I just hit unpause, it would have worked correctly. But anyway, okay. So we've created our array. We've shown it public so I can see it right now. Now, let's go one step further, maybe 2 steps further. And we'll say what we want to do is if the enemy falls below the top of the bottom of the screen here, Oh, wait, not our enemy behavior, our soldier, our dropped item. When it falls below that, we want to destroy one of the baskets. Now, our inclination might be, go ahead and just, get into that code and, like destroy one of those baskets. And that isn't good object-oriented programming. What we want to do is we want to ask the player to destroy one of its baskets. Okay, that's the better thing to do. So let's do this. GameObject.find, and we're going to look for the player. And let's make sure we get the name right. GameObjectFind.player. So this is going to look through the list here, through all of our game objects in the scene. It's not super efficient to do this all the time, but let's do it for now. So we're going to find the player game object, and we're going to get the component called what? It is called player behavior. Player behavior. And we would ask it to destroy or lose a life or destroy a basket. What do you want to call it? Destroy, a basket. So this is asking the player object to call something on its script. We don't want to actually go ahead and start messing with these objects here, to mess with the array externally. We want the game object to do the right thing for us, right? So we have to define now this destroy a basket function over in the player behavior, though. So let's create that function, and we're going to create it to be public void destroy a basket. And now we're going to want to destroy one of these baskets. So we know we have 3 baskets. So now we want to start getting sophisticated. So let's say int life count. Now initially, when the game starts, we have 3 baskets. We have 3 lives. 3. Okay. 3 lives. 3. So every time we lose a life, we lose a basket. That's why they're linked together, right? So that's that. So 0, 1, 2, 3, those are our baskets there. Now, so we can come down here and say, well, if life count greater than 0, we want to destroy one of those baskets. We want to destroy one of the baskets. But which one? That's the question. Now we could say here now life count is greater than 0, but life count is initially what? 3. That's the number of lives we have. Now the array goes from 0, 1, 2. It doesn't actually go to 3. 0, 1, 2. So if we said, all right, we destroyed a basket, we'll say you destroyed a basket, that means life count minus minus. That's losing a life. So that will now be 2. So it went from 3 to 2. So what if we just plug in life count? Maybe that does the right thing. Whoops. I'm debugging now. That's okay. So we'll play the game, hopefully. There we go. Drops one. And we haven't missed one yet. Let's miss one. All right, the top one. The next one. And that one. And no crash. And now if you notice, I can't point at it. But you see the little focus there over on the left-hand side? That's actually showing me where the player is. So I have succeeded in creating some actual gameplay here. If I miss an item, I lose one of my baskets. Okay. Any questions? So that's why arrays are convenient, right? So now next we'll tackle the, what should we next tackle? We can next tackle the soldier. Let's see, the soldier was doing most of the heavy lifting here, right? It was the one that was deciding, okay, if it hits the, it fell off. Wait, here's our soldier. There we go. Our dropped item doesn't need to be soldier behavior. It could be dropped item behavior. Normally I call it dropped item behavior because it really could be anything. So we said destroy all of the baskets. All right, we did that. Let's now comment over here because that's what it's doing. Now it also needs to destroy all the other dropped items. All right. Now, this is not going to make as much sense until we have multiple dropped items on the screen. So let's do something spectacular. All right. Now, the idea is that every time, let's see which you want to introduce here. Let's get it to the point where we're going to have lots of them on the screen at once first. Let's make some progressive gameplay. Is anyone still there? Okay, make sure. Double check. You guys are all so quiet. Like everyone's like totally intensely. All right. All right. So it's like, all right. We have two options. I'll let you now. We're just speaking of like too many programming languages. We could either start making the Snow Kid throw or drop our soldiers faster and faster, or we could try to do some of this same stuff using Bolt. So we could do a poll. Yep, gotta love the polls. Now let's see. I gotta remember how this Bolt or advanced behavior. Oh, what happened? Oh, I have to put a. Yeah. I thought it would be smart and just no, that's not what I want to do. All right, stop it. All right. If I edit that. Nope. It's not that smart. All right. All right, people want more advanced behavior before getting into Bolt. Fair enough. Fair enough. All right, advanced behavior. So we have our snow kid, this snow kid should be dropping snowballs. That would be way more appropriate, right? But we could always add that later. All we need to do is swap out the sprite, and then the snow kid would be dropping snowballs, right? So this is why we can have placeholder art. It'll be good. Or we could just swap out the players or the snow kid's art for some, ship that flew back and forth. That'd be cool too. But let's not worry about that. Let's instead worry about how Snow Kid acts. So Snow Kid up here, Snow Kid has Snow Kid enemy behavior, right? So enemy behavior. And right now, enemy behavior is pretty dumb, in which case all it does is goes left and right, and every 1.5 seconds, it drops a soldier. And just out of, I'm going to call this drop item. I'm going to speak a little bit more generically, right? And let's see. I may regret that because now. Remember to. Come over here to see if it did. Nope, didn't do that. So for now, I'm going to say prefab. We'll use this soldier for the dropped item there. All right. So Snow Kid again. And Snow Kid got his enemy behavior. So the initial version of Snow Kid now had a starting velocity, and every 1.5 seconds, we use this invoke repeating to create this how often it would drop items. Now, there's invoke and invoke repeating. Invoke, the sort of big brother, the starting version of invoke, drop item, that just takes a delay, right? Invokes the method name in time seconds from now, right? So we can say 1F, and it's going to start it in 1 second. But it's not going to repeat. It's only going to drop 1 and then be done, which is no good. So this is a wonderful hard-coded number, which is also. So let's do this. Let's say, okay, public, let's make it for now, public float drop rate is going to be 1.5. And let's put it there. So now our drop rate is set according to this parameter. Now we could come up here and change it on our, after we save that, it'll show up in our enemy behavior. So how do we get it to happen again? How do we get it to happen after that? Well, we have drop item. We instantiate our new dropped item. And what we can do, anyone have any ideas? Anyone want to suggest anything? Open it up to discussion. Well, not loop it. It's sort of looping it, but it's not actually looping it. Okay. So the idea is, how do you want it to happen recursively, sort of. Okay. So what we're going to do is we're going to call invoke again. Right. And we're going to say the same thing. We're going to invoke drop item at the drop rate. Okay. Now, if we were to actually be calling drop item inside of drop item, that would be truly recursive and truly dangerous, because potentially it would just repeat forever. And if there was a tight loop and there was no time in between, it would create this tight infinite loop and be bad. Right? If I just said, I hesitate to even type this, drop item, that right there. Drop item, it would let me do it. It'd be happy to let me do it. So that would be an infinite loop. right? Drop item would do that, and then drop another item and do that over and over again as fast as possible. I don't want it to do that. Because first off, I want to give the engine a chance to do other things. The engine has to take care of the physics and take care of user input and do all the, draw on the screen and all that kind of stuff. So I need to allow system calls to happen. I want to schedule this in a system-friendly way. So invoke schedules the drop item call. It doesn't actually call drop item here. It just schedules it to happen 1.5 seconds from now. Okay. So it does the same thing as the other version, but it gives me an important opportunity. Because now I have control. I have a variable that I can use to tune the play of my game, that I can tune, that I can modify on the fly to shrink, right? I want to shrink this number. Every time it drops an apple, I want it to speed up a tiny bit, right? And the question is, of course, how much, what should it change that to? So we could say if drop rate is greater, it's greater than what? We want to give it some limit, some floor to say, okay, we don't want it to be infinitely fast. We don't want it to be dropping 100 apples a second. That would be, right, 10 apples a second. That's pretty fast, right? So as long as the drop rate is bigger than 0.1, we're going to allow for scaling of drop rate. So we have a lot of different options. Now, if we wanted to just shrink it by a little bit, now one of the ways we can do this is we can multiply it by any number that's less than what? Less than 1, right? Between 0 and 1, any number is going to cause it to decrease. And then every time it's called, it's going to decrease again. So it's going to continuously kind of shrink and shrink and shrink, right? If I set it to 0.9, for example, 1.5 times 0.9 would give us, 1.35, something like that. And then after that, it would be, subtract off another 1.35, and then 1 point, it gets smaller and smaller and smaller. So let's try that. It's going to go pretty quick. That would escalate pretty quick. So let's escalate 5%, basically. Right. So every time it drops an apple, it's going to get 5% faster this way. Now, these things that I just hard-coded are awful. They're hard-coded numbers again. Don't do that. So we'll call this increase rate. And the last one will be public float. And it's going to be min rate 0.1. So we'll say if drop rate is greater than min rate, and we'll call this not acceleration yet, is it? No. That's going to be off. And let's see. You see it shrank down a little bit. What's going on here? 1.45. Why didn't it? That's weird. Drop rate times equals increase rate. Oh, wait. Huh. I did that in the wrong spot. I did that in start. I shouldn't have done that in start. That should have been done here. There we go. Probably should do it before. For the next time. The next one gets faster. So now let's see. Now it's really going to do the right thing here. There we go. So 1.11, 0.04, 0.99, 0.94, 0.89, 0.85, 0.81. Faster and faster and faster until we start getting multiple ones on the screen. Now, I happen to be very good at this game. So, anyone want to guess what's happening? Nope. Okay, there's an interesting phenomenon. All right. Remember we made SnowKid up here, and SnowKid has a rigid body 2D on it. And, oh, okay. Sorry, two things happen. All right. It's not SnowKid that's causing the problem. It's the soldier itself. So we jump to the soldier here. The problem is that our prefab for a soldier, now our soldier has a rigid body 2D and a collider. And the soldier is programmed so that if the soldier collides with something, it destroys itself. It destroys, right? Something collided with me. Now, you'll notice here, maybe, some of you already have noticed this, mentioned for the stream, that yes, it's colliding with itself, right? The moment it starts spawning at a fast enough rate, it can't get out of its own way, right? So one soldier is spawned, the next soldier is spawned immediately after or close enough so that they're on top of one another and they automatically destroy themselves. I never even have to worry about it. I would get a really, really high score really, really, really fast. Thankfully for us, we have some ways to take care of this. Now, I'm going to introduce a couple of things. Now, if we wanted, this is actually most of these things, and always refer back to lectures because let's see, if I go back to the lecture slides and we look at collisions, tags, and destruction. So way back when we started talking about collisions, tags, and destruction, rigid bodies and colliders. All right. Dropping and catching apples. Right. So we got to this point where we could have colliders. We had box colliders, and we have it set. So on collision enter 2D, we have code that executes. Right. We're not using triggers. We're using actual colliders here because we want physics to be. Now, we could have used triggers for these as well, actually, because they don't bounce off one another, but they are triggers. That wouldn't solve our problem, though. One of the things we do have, there's two methods to sort of, when you have items or when you have objects, you can use two things. One called tags or tagging. You can use tags to tell something about that object, right? And tag is just a string. So we can attach a tag to an item and say, okay, what's the tag set to? So we'd say, if we're colliding with an enemy, lose life, for example, excuse me. So that's the thing we would use tags for. Tags answer the question, who are you? Should we collide? Should we be allowed to collide? A tag is a reference word you can assign to one or more game objects. For example, you might define player tags for player-controlled characters and an enemy tag for a non-player controlled character. You might define that the player can collect in a scene with the collectibles. You could even have baskets. You can compare, you can find a game object with that tag, and so on. Another thing you can do, and the text does this, if you have the text, they mention this, you could find all of the things in the scene. So for example, if you created lots of, and don't do it this way, I recommend you do it like proper list way, but you can do it this way. We can demonstrate. You could say, find all of the apples in the current scene, anything tagged apple, destroy that. Right? So you can use a for each, and there's a find game objects with tags. So tags are pretty versatile. Tags are also, they tend to be expensive, right? And checking tags may seem to be sort of tedious, right? Something it wouldn't be great if you had a bit more of control over that. And you do. There's something called layers. Layers are a far more elegant way to manage your collisions, right? So layers are used throughout the Unity editor as a way to create groups of objects that share particular characteristics, not just an arbitrary string identifier. They actually, can be used. You can set multiple layers and so on. So one important use is to manage collisions in physics, but you will encounter more as we go on throughout things. Layers are far more sophisticated than tags. They also are a lot less overhead to work with. So user layers and tags are created via the tag and layer editor, and they are manipulated where they're managed, or at least the layers are managed via the collision matrix, which is in the project settings physics 2D. Okay, and there you can define, do apples collide with one another? Do apples collide with trees? Do, basically what layers collide with other layers, all right? And then we can use destroy to do the right thing. All right. So let's go back, let's apply what we just learned. So soldiers, the soldier prefab here, is currently, you'll see it's untagged, right? So here's the soldier. It is untagged, and it is on the default layer. So we have two options, and if we want, we could go ahead. We'll use both, right? You can have lots of different tags if you want. So we're going to go ahead and say add a tag. Let's say plus, and we will call this dropped item. So that would be a dropped item tag. Now we can also go ahead, let's define a layer called dropped. And this one I'm going to say call it dropped items, right? Because they're all going to be, this is a item that is tagged as a dropped item, but it is on the dropped items layer, right? So if I wanted to fix the problem now that we have without editing any code, let's go back and select this guy. Now I've created those tags. I could say, oh, dropped item there, put that tag on him, and put him on the dropped items layer. And you really don't need to do both, but you can do both. We'll just demonstrate it both ways. So now the player has, or the enemy, the dropped item has that layer. So I can come up here and I could say, okay, let's go to project settings, and we'll go to physics 2D, and we'll look at the collision matrix. And what we want to tell it is, now look, we have dropped items up here and dropped items down here, and there's a check there, meaning that dropped items can collide with other dropped items. And I'm going to turn that off. So now dropped items can collide with anything else except for other dropped items. So I haven't used the tag at all, and I haven't changed any code. And I've clicked this start button a whole lot of times, and it's 4:20. So let me win the game. And now it's going to be far more challenging. because they're not going to collide with one another. There we go. There we go. Now you'll notice at this point, if I miss one, I'm really in trouble because missing one is basically missing a whole bunch, right? That's the reason when you miss one, we want to destroy all of these, right? Boy, that's spitting a lot of those out there. That's like perfect. I love that. That looks great. Yeah, it's like watching solitaire when it bounces off the end, right? So the next thing would be to say, okay, well, now come up with some way of managing the destruction of those. Whoops. So we're at 420, and that's given lots of food for thought. I'm going to go ahead. I'm going to make sure to put the slides up. The slides did mention this is one way, and you can try this out if you want. Normally, I don't recommend doing it this way, but this is one hint here. For each game object apple in game object, find items with tags. So we could use our dropped items and destroy. You know, if you have to leave, go ahead and leave. If you don't, I'm just going to do it this way just so you can see the results. Otherwise, see everybody on Friday if you want to hang out and watch this actually work. Let's destroy all other dropped items. So we'll just say here inside of update for each game object, and we'll call it dropped with the tag dropped item. Destroy. Now, dropped is being, that's a local variable. Okay, that's cool. So we're not, so we're going to go ahead and destroy all of them. And this, what we want to do now, we don't even need to do this anymore, right? Because that's going to be destroyed as part of our, we're one of those. We're a dropped item. So we can just get destroyed as part of this other destruction here. Did I press attach to unit again? Didn't I? All right. No debugging necessary. Here we go. Gonna get a bunch of them going. It's much more fun once you actually get some sounds and goes boink, 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 you know. All right, there they go. Have a great week, everybody who's leaving. And ready? Okay, let me, there. Okay, so that's the idea. That's the mechanism that you want. I recommend really doing that as using a list to maintain. And I'm going to want you to demonstrate that using a list in here rather than this find all game objects with tag. This is expensive. Going through every game object in your scene and checking its tag, you know, even though there's some hashing involved and some optimizations, this is potentially an expensive operation, right? Because it's going to go through all of your game objects checking against that tag, which is not great. I'd recommend using a list for that, and I'll show you how to do that. Have a great week. See you all on Friday.